Hello and welcome to this video on applications of recurrent neural networks. In this particular video, we will be basically discussing some of the very famous applications, including activity recognition and image captioning and machine translation. There are several other applications that we need to discuss, but I've chosen these applications because these applications, they actually cover both computer vision as well as natural language processing. And also they cover different kind of recurrent neural network architectures that are really famous. So let's dive in. Okay, one of the most popular applications of recurrent neural networks is human activity recognition. Sometimes this activity is renamed as action as well. So human activity recognition or human action recognition. The problem is, the problem here is given a model. I'm not saying that this particular model is a recurrent neural network. That is some machine learning model that accepts as input a video clip and outputs an action that a particular person or multiple persons are performing in this particular video clip. And these actions or activities, they belong to some predefined set of actions. For example, sitting is an action, standing is an action, walking is an action, running is an action, dancing is an action, boxing is an action, swimming is an action. You can define a lot of action categories. One question you might, or one concern you might have in your mind is why on videos? Why not on images? So, for example, if we just it looks pretty cool that given just an image like this, one can easily find out that this is basically a sitting action of a person. This particular posture reflects that a particular person is basically standing, and this posture is actually telling that a particular person is walking, and similarly for running. So why really the videos? It turns out that there are several actions depending upon several varying situations that alone a single image is it is difficult to actually define the action based on just one image. Actually, there are certain actions for which a certain kind of frames can be selected, that two different actions, they turn out to have the same internal kind of image. So single image may give multiple interpretations for multiple actions, and all might be valid. So it turns out that for action recognition, we need some temporal images. So we need a sequence of images, which is basically a video clip rather than just a single image. And it also turns out that for the data set, for example, on which you are going to build this particular kind of model, machine learning model, that data set may contain videos that has varying length in terms of the number of frames or the time, the total. For example, this video clip might be of 20-second clip. This might be, for example, a 30-second clip, and so on. So may have different length of the video sequences at the training time, as well as when we really want to evaluate the performance of this model at the test time as well. Further, different video clips, they can have action represented in different speed. For example, maybe in a 20-second clip of this particular walking video, the person is performing a walk that is, or an action that is more speedy in the same in another 20-second clip that the same action is performed a little slowly. So so the temporal nature of the problem, where the input lengths of videos, they are varying in the training data set, and at the deployment time, at the run time, at the test time, the sequence upon which this action has to be described, that length of the video sequence may be different. So this particular sequential order of the frames in a video that actually give rise to the necessity of machine learning model that best suited for it as a recurrent neural network. There are other models earlier than recurrent neural networks like linear dynamical systems or hidden Markov models, but it turns out that the capacity of recurrent neural networks is actually much more than the individual linear dynamical systems or hidden Markov models. And actually it encapsulates the beauties of all these kind of time series models. So let me just show you some real data sets that are available for activity recognition here on internet. So this page, for example, has a lot of video data sets. It has basically links to a lot of video data sets for different kind of tasks. For example, if you see this HMD B51 data set, it actually has let me actually make a little bit more zoom here. So this data set basically has 51 action classes, and it has total or more than 6,000, actually 6,766 video clips. And not necessarily that all these clips have the same length. They can be variant length, RGB, and I mean with a lot of kind of varieties. Further, you can see this UCF101 sports data set that has actually more than 30,000 videos on more than 100 action classes, different action. Similarly, this sports 1M or sports 1 million has many more videos, and the total sports classes, sports actions are around 500. And similarly, you can see, for example, several other activity recognition data sets, action recognition data sets based on video clips. There are several of these. Yeah. So here you have YouTube 8 million. And several other data sets that are freely available. This human activity recognition, given a video sequence, I really want to find out what is happening there, what a person is doing. It is actually, it actually becomes really important in several surveillance scenarios, security scenarios inside a building. For example, you can track your, you can track other people, you can track your employee given a particular task, whether they are performing that particular task or not, what are they doing it, what kind of stuff. So this this kind of model, if available, actually give a lot of monitoring control, and with precise accuracy. These are basically the latest recurrent neural networks that actually give rise to a much more accuracy than the earlier ones. So human activity recognition, human action recognition, even action synthesis. There are other recurrent neural networks that can build action synthesis as well. So let's have some more applications of recurrent neural networks. Image captioning is another very popular application, and particularly this is a problem in which RNN really is succeeding very, very well as compared to the traditional time series models. The problem setup is the following. You have some machine learning model, let's say machine learning model. Here's some machine learning model that you really want to build, which takes as input an image, an RGB image, or some image, maybe a grayscale image or an RGB image. And the output of this model is text, or maybe a paragraph, or maybe a string, maybe a lot of sentences that actually explains this particular image. So take an example that I've taken from the Keras GitHub. Take an example, for example, if this is the input to the model, that image is input to the model, the output here is, as you can see, that the text is basically the output of the model. A young boy is playing basketball. That is a description or the caption of this particular image that the model is required to generate. See, for example, another image like this image. And the caption the model has generated for it is 2 dogs play in the grass. So, I mean, the authenticity of this caption may vary. You may add more details. For example, a young boy is playing the basketball, and and several other boys, they are sitting behind. You may extend this caption. But see, for example, the caption that is available, although it's a little short, but it actually explains the image. And this is very complicated problem. And given the image, you're going to actually explain the image via text. Similarly here, you can have a different caption that may be valid. For example, 2 dogs play in a grass, and there are certain trees behind the area. And I mean you can have a different explanation, but this one is really a cool caption that the model actually came up with automatically. Similarly, for this particular image, you can see the caption: "A dog swims in the water." I mean, you can see it is not very easy to actually judge that this particular object is a dog, and further, it is actually swimming in the water. I mean, getting that all these scene, it belongs to water, and the dog actually swimming in there, that's difficult. At least before the birth of recurrent neural networks, it was close to impossible. See, for example, this image, a little girl in a pink shirt. So see, for example, that how detailed caption is there. A little girl, first of all, the girl is little, a little girl in a pink shirt. So it also detects that it's a pink shirt, is swinging. That's amazing. I mean, the result of this particular for this particular image is really amazing. You can see how detailed caption is that and how accurate is this. A group of people walking down a street. So that's the caption for this. The caption for this is a group of women dressed in a formal attire. You can see the caption for this. 2 children play in water. I mean, yeah, it actually came up with the description that all this scene actually corresponds to water. And these 2 objects, first of all, these are 2 objects. Second, both are kids, they are children. And you can also see a dog jumps over a hurdle. So that's so a model actually automatically detects that this is a hurdle, that's a dog, and actually the dog is jumping over a hurdle. So this image captioning actually is a really cool application where we really want to so for example, you have a database of images and you want their automatic explanations, or you want to generate another database of text explaining those images. Yeah, I mean, several applications that came up with. And by the way, the best machine learning model to date that is outperforming all the existing models is a recurrent neural network that has convolutional neural networks as layers. Let me show you a data set corresponding to these kind of applications. For example, this cuckoo data set is there, sometimes called Coco or Cuckoo. That's data set that is available for object segmentation, recognition in context, and particularly this data set basically also belongs to 5 captions per image. So it has a lot of images, and each image actually contains a lot of captions. So while training the model, you need to have a lot of data set to actually train such a model that actually perform this kind of task. So such a data sets, for example, several data sets are available. One common and more popular data set is Coco data set. So let's discuss some more applications of recurrent neural networks. Machine translation is yet another application in which basically a problem in which recurrent neural networks basically show its power. If I say that recently in natural language processing, sometimes abbreviated as NLP, most of the work or most of the important work has been done in machine translation because of the importance of this problem. Or maybe if I'm too biased, I could say that maybe more than 95% of the efforts have been built to this particular problem, and different components to build this kind of the solution of this kind of problem. That might not be a very biased or harsh statement. This I guess the numbers may go a little up or down, but that's actually is the case. And guess what? The most boost to this particular problem, the solution to this particular problem, is given by recurrent neural networks. Let me explain the logistics of, let me set up the problem. What is the problem? And I will also contrast this machine translation problem with the existing applications that we saw. For example, one of those were, for example, if we earlier saw image captioning, and then we also saw human activity recognition. So I will contrast the setup of this problem with the two problems also. So the goal is given. So you have to come up with a machine learning model that actually accepts a text in, let's say, a particular language, let's say English. So let me call that as English text. And let's say it converts the text to equivalent, let's say, French text. And the machine learning model should actually convert any piece of text from one language to another language. Here I have taken example the conversion from English text to French text, but it can be from English to German, or German to English, or from any language to any language. So that's the goal of machine translator. Let me contrast this problem with image captioning, for example, that we saw earlier. Image captioning, for example, takes input as one image, so that's image, so just one image, and outputs a lot of text. So in terms of words or sentences, the output has varying length for different images. So you come up with another image, you may have a text length that is different than, so the length of the output in terms of words or sentences, that may vary with respect to different images. Different images, they may have different caption lengths. Let me also go to, so that is image captioning. Let me also go back to activity recognition, human activity recognition, where you need to come up with a model that actually generates a single output, the class of the action, or the action class. So that human activity recognition. But the video it takes, it may have a different number of frames. So that's the video, and here these arrow represents the length of the video in terms of the frames. So for different videos, for the same action or for different actions, the length of the frames, they may vary. So this problem is sometimes known as many to one. This problem is sometimes known as one to many. But see this particular problem, machine translation. If I draw the machine translation problem just with the analogy of the number of arrows that represent the length of the input and output, here the English text, a particular sentence may have different length, and the corresponding, let's say, French sentence as an output may have different length. So for example, one sentence of English may be shorter and the corresponding sentence in French may be lengthier, and vice versa. One sentence in English may be lengthier and the corresponding sentence in French may be lengthier or smaller. So this particular problem in machine translation is sometimes known as many to many. And we will later on see that there are encoder-decoder kind of networks, recurrent neural networks, that actually solve these kind of problems. But nonetheless, these are recurrent neural networks that actually give rise to the best solutions that are available today. And this machine translation also relies on language models. This is not only the machine translation that actually relies on language models. actually speech recognition and automatic correction in several languages. They also rely on underlying language model, and these language models, they also are built using recurrent neural networks on very large corpus of data, very large body of the data for that kind of language. Let me show you some machine translation project or data sets that are available on the internet. For example, if you go to internet, that's natural language processing.nlp.stanford.edu projects, NMT, neural machine translation. And so this page actually contain code base as well as different data sets they use. For example, English to Czech data. That is actually pre-processed data. You can have, for example, access to raw data as well. And this data set, for example, contains these kind of pairs, training data, test data, and the word vocabularies, dictionaries, and all that kind of stuff. A lot of terminology that is used in natural language processing. Not only that, they actually have made public these pre-trained models, ready-to-use models, these recurrent neural networks, attention-based, and other models. They actually are available pre-trained models ready to use on your data set, or maybe fine-tuned on using methods of transfer learning on some new data sets as well. So there is a large body of machine learning experts, natural language, the people from natural language processing and machine learning that actually are doing work on this particular kind of problem, machine translation. And a lot of stable apps actually are now available. A lot of stable software are now available that actually do a very consistent and very kind of stable kind of translation that is really great. And it is improving day by day due to the blessings of recurrent neural networks. Although there are so many other applications of recurrent neural networks and very famous applications, for example, speech recognition is a really famous application, and the recurrent neural networks, they are best suited for those. Also in stock market, for example, stock price prediction is yet another very, very powerful application of recurrent neural networks. Due to the constraint of time, we have just discussed a few of those, including activity recognition, machine translation, and image captioning. We have actually discussed other very famous applications along with their implementations in our full course on AI sciences. So those who are really interested to see the details of these applications, as well as the implementation, how to build recurrent neural networks in TensorFlow and other deep learning frameworks. So I welcome you to please go and enroll I welcome you to please come and enroll our full course on AI sciences, where we discussed each of these applications in a bit more detail.